Alright, today we have topic 1.4, Quadratic Applications. What we're going to be going over in this lesson will be dealing with more of the real-world situations, and we'll be using quadratics to solve real-world problems. An example of which it will give you an equation that describes a certain event or certain path that an object will follow. Through this, you will want to use your calculator. All we're going to do is hit this using a calculator. We're not going to work it out by hand. But, alright, so now let's look at example 1. Example 1 has an illustration to it. Let me get that illustration pulled up for you. Alright. I'm going to go ahead and read the question. The path of the ball is thrown upwards and can be described by the equation h equals 35t minus 5t squared, where h is the height of the ball in meters and t is the time in seconds. Now, as a quick note, it is going to be very important that we deal in terms of meters. We must write our answers in terms of meters, and our answers have to be in seconds. It is very critical that you don't just write a number. You put M for meters. You can put seconds. You can write out seconds. You can abbreviate seconds. Doesn't matter. We have to tell what we're dealing with. Now let's look at our illustration real quickly, knowing what we know from our example. We have here our height. Our height is shown by our y-axis, and our t is shown by our x-axis. And we imagine an object, in this case a ball. Let's imagine this object going up. We throw it up in the air, and now here it comes back down. That'll be the path that it takes. If you started a stopwatch whenever you threw the object up, it would increase until it made it all the way back down. Our time would increase as our object went up and then came back down. It has here, it shows a distance or a height. Say after 5 seconds we want to know how high the object is. We come over 5 seconds, we move up. This will be that point. So, another quick thing we need to look at, and it'd be a good idea for you to write down on your paper off to the side, just like kind of what I have here off to the side of your illustration. If our t is given, then on our calculators, we will use, after we put it into y1, our equation, we will use this. We will go to second, calc, and then we will want to choose value. We will be putting in a value. If our t is giving, we will be putting in a value, and then it will give us what our height is. Now, if h is given, we got another step. We're going to set y2 equal to h. Then we will go to second, calc, and then we will find our intersections. Just like before, we'll find our intersections, but instead of this time setting y2 equals 0, that will find us our roots. But let's say it gives us a height somewhere in this area here. If we put that in for h, well, it will ask how long does it take for this object to get this high. Well, this object will be at this height here and here. It will be at both places. So you'll have two answers to that. But that is how we're going to use our calculator to solve these. So let me go over here and let me grab my calculator, pull it over, and let's look at our equation. Go ahead and turn on my calculator. It gives us our equation, and I have it written down right here for you. H equals 35t minus 5t squared. Part A to this example, how high is the ball after 3 seconds? So what is it giving us there? Is it giving us our h or a t? 3 seconds. It's giving us our time. So, knowing that, if t is given, let's go ahead real quickly. We're going to put our y1 equals our equation, 35. We'll use an x minus 5x squared. Okay, so there's our equation. It gives us t. Following our rules, second, calc, value. Looky there, value number 1. Hit enter. Now, we look at this, and let's look at our graph. You saw that the graph does not look appropriate. So let's go over here. I'm going to just view just the graph. We can't really see that very well. Let's set our window. Normally, what y'all's will probably look like is something like this. You can't view that very well. So we need to set a window. Now, there's no reason, if you look right here at this, there's no reason for us to have a minimum x. If you throw an object up in the air, it's not going to be at a minimum value. So we're going to set a 0. Now, for the sake of trial and error, I'm going to leave my x max at 10. My y minimum, it's not going to go below the ground. So I'm going to leave a 0 here, and let's look at trial and error. I'm going to leave that as it is. So our x is going to be good. I mean, we can see where it's going to leave right here, and it's going to come back down. Our x is fine. Our x is at a good set. Now, our y, we cannot see all the way up. So I'm going to go to my window. I'm going to come down. I'm going to put in another number, 50. Now our scale, we need to adjust it. I'm going to adjust it to a 5 just as a trial and error. It's starting to get there. We still need to see the top. Let's go a little bit more. Add a 75 and leave it as a 5. And there we have it. Now we can see what we're working with. So I'm going to go back second, calc, value. And it gives us 3. We want to know after 3 seconds, and there's our point. After 3 seconds, that is where our ball is. So our y, we're looking at that y value. Let me go over here and we're going to put A. Our y value, it gave us 60. So our answer is 60 meters. And let's look at B. Grab the calculator. After how many seconds will the ball be 50 meters high? So what does it give us there? Does it give us our h or our height? Or does it give us our time? It asks us for the time. So it gives us our h. If h is given, set y2 equal to h. Go to y2. It gives us 50. Now we're going to go second, calc, and we're going to find our intersections. Let's look at our graph. Let's look at it. There it is. There's our line, just like what I have drawn here. Second, calc, our intersections, which a shortcut is 5. I'm going to move on, and I want to find, because it's going to have 2 answers. Remember, it's going to have 2. I'm going to get close to this one. Hit enter 3 times. Our intersection is 2, so one of our answers is 2. Now, we saw on the graph there's going to be another answer. Second, calc, intersection. Scroll over, and I'm just going to get close. That's close. Enter 3 times. And 5. 2 and 5 seconds. That is the answer. Now let's look at our last one, which is C. C asks us, when will the ball hit the ground? Does it give us a height? Does it give us time? It's asking for when, so it's asking for our time. And it says, when will the ball hit the ground? Right there, it gives us a height. If you're on the ground, what is your height? Your height at that point is 0. You have no height. So, our y2 would then become 0. Second, calc. our intersection. Now the question is, are we looking at this point? Because right over here, it will be at 0. If I move all the way over, that'll be at 0. But it's asking when will it hit the ground? If you throw a ball, you want to know when it's going to hit the ground. You're going to want to know as it comes down, when will it hit the ground? I'll move to my other line. I've got this chasing along. See if I can move it back. There I am. Chase along the line. I'm going to get it somewhere close to the bottom. That's it. It follows the ball. It hits the ground. It wants to know when will it hit the ground. And at this time, our x value, which is our t, is 7. So the answer is 7 seconds. All right, so I'll leave example 2 to you, and let's look quickly at example 3. Example 3 says the area of a rectangular piece of cardboard is represented by the equation W, parentheses, 2W plus 3, close parentheses, equals 9, where W is the width of the cardboard in feet. And then it asks you to find the width. So, I have here my equation up on the board. And our first thing that we have to do is we have to set this equal to 0. What we're going to be after here are our solutions. And any solutions to a quadratic, as we've known from 1-3, will be where they cross the x-axis, the zeros. So we have to have this set equal to 0 on one side of the equation. In order to do that, subtract 9 and subtract 9. We're doing that from both sides. That will get us W, 2W plus 3 minus 9 equals 0. I can remove that line up to there. Now, since we have this, then we can simply come over here, pull up the calculator. I'll need to go through here and clear out from my previous clear. Now I'm going to go ahead and leave y2 is equal to 0 because this is y2 on this side. y1 x, oh, I'm sorry, there's an x, parentheses, 2x plus 3. Close the parentheses and then minus 9. Now let's go ahead and let's look at our graph. Alright, so I've got my window set from the previous question, and we can see where it comes up through this manner, but we don't see the other half of it. So I'm going to go ahead and I'm going to zoom standard, zoom 6. Alright, so now that gives me a real good view of what we're after on this graph. So the question is, find the width. Now I'm going to look at my calculator. I've got two solutions. The solutions are where it crosses the x-axis, our zeros. We've got one in this area and we've got one in this area. If I'm asking you for the width, in this case, let's go ahead and use this, the width of a piece of cardboard, are you going to use a negative number? Your answer on that should be no. We can't use negative for describing a width of an object. An object cannot be negative in width. So you can throw this out. This cannot be one of your solutions. So when I go to second, calc, and I'm going to find my intersections, I'm going to move to this side, get close to this one in area. 1, 2, 3. 1.5. Now let's look and see what it's dealing with. Represented by the equation where W is the width of the cardboard in feet. So now our answer must be is in feet as well. W equals 1.5 feet. And just so that you can see, I got that from this right here, our intersection, our x equals 1.5. That is our final answer, and that is how you will solve questions to that extent.